All right, ladies and gentlemen, so today we're going to talk about lesson 6.1, which is solving systems of equations by graphing. And so much of this today is going to sound familiar. It's similar to what you did last year when you were talking about systems of equations. As far as your notebook goes, please make sure you leave a blank page so that you can glue in your table of contents when you're in the building next. If you're learning at home, make sure you find that table of contents PDF, print it out, and glue it in so you're ready to go for this chapter. So in this chapter, there are two skills that we're working on. The first one is representing constraints and systems of inequalities. And then the one that we're going to focus on the most for this whole unit is that REI 6, where we are solving systems of linear equations exactly and approximately, focusing on pairs of linear equations in two variables. So most of the systems we're going to talk about are going to have two linear equations, and we're going to figure out how many solutions and what those solutions are. First, we have some vocab. The first vocab term is that idea, systems of equations. A system of equations is a set of two or more equations with the same variables. A solution to the system is an ordered pair that makes all equations true. And like we talked about before, we can have systems that have one solution, no solutions, or infinitely many solutions. To build on top of that idea, though, we're going to add in the ideas of consistent or inconsistent systems and dependent or independent systems. That first idea, consistent systems have at least one ordered pair that satisfies both equations. Inconsistent systems have no solutions. There is no ordered pair that makes the system true. Well, if we're talking about our consistent systems, we can have dependent consistent or independent consistent systems. A dependent system is a consistent system with infinitely many solutions. An independent system is a consistent system with exactly one possible solution. Make sure that you have these three vocab terms in your notes. And then add in a little sketch to help you remember the differences between these three types. If we're talking about intersecting lines, like I have in that first graph, get some color here. This one here, I have intersecting lines. Well, if I have intersecting lines, I know I have exactly one solution. If I have a solution, it's consistent, and the fact that I have only one solution tells me that it's independent. So I can use both of those terms to describe this system. Well, this one here, it's kind of hard to tell, but I've really graphed the same line on top of itself. I have infinitely many solutions. Because I have a solution, it is consistent. And because I have infinitely many, it is dependent. So I can describe this system as consistent and dependent. If I have parallel lines like I see here, there are no solutions. There's no points that are true for both. So it is an inconsistent system. I can't talk about dependent or independent. In this case here, the only term I can use from today is inconsistent. So now let's practice. If I'm using this graph here, and this looks similar to the types of graphs you're going to find on the homework, I see that these lines are already graphed. I don't need to do anything to them. So if I see 2y plus 3x equals 6, well, that's this one here. I'm just going to trace over it in purple so I can find it better. And I see y equals x minus 1. Y equals x minus 1. That's this one right here. Well, if I look at this, I see that those two lines intersect. So I know that there is at least one solution. So I can describe this as consistent. Because it intersects at only one point, it's consistent and independent. I could also say that those lines are intersecting. I could say exactly what the solution is if I determine what my x and y values are of this point where they cross each other. But this part here just asks me about consistent, inconsistent, and independent or dependent. So my final answer would be these two terms. On the next one, I have y equals x plus 4. Well, that's this line right here. And I'm still thinking about y equals x minus 1 that I traced over in red from the first problem. If I'm looking at these two lines here, I see that they are parallel. Parallel lines tell me that the system is inconsistent. There are no solutions. Because there are no solutions, I can't use any other terms to describe it. So independent, dependent doesn't matter. This system is inconsistent. There are no solutions. In your notes for these ones here, I'd like you to write out the equations of each line and sketch what it looks like. So you can sketch in your notebook something that looks like y equals x minus 1, and the purple one that looks something like this, so that you have a sketch that shows you what a consistent independent system looks like. A sketch of an inconsistent system. Well, if I use the two lines that we had before, I had y equals x plus 4 and y equals x minus 1. Moving on, this time I want to graph the systems of equations and determine the number of solutions. Name the solution if possible. So I'm going to figure out if it has infinitely many solutions, if it has no solution, or if it has one solution, I need to name that solution. I need to give the ordered pair. So in order to graph these, the first thing I need to do is I need to convert them. Well, I don't need to. I can graph from the form that they're in right now, but using the skills that we have, we are most comfortable graphing in slope-intercept form. So I'm going to turn this line into slope-intercept form by taking away x from both sides, and I get 3y equals a negative x plus 6. To get y all by itself, to turn it into that y equals mx plus b form, I'm going to divide both sides by 3, and I'm left with y equals a negative 1/3 x plus, well, 6 over 3 is 2. To graph this line, I know I need to start at that y-intercept of positive 2, and my slope tells me down 1 over 3. Let's do it again. Down 1 over 3. Oops, over 3. There we go. And I'm going to connect and extend across the page. When you are completing this in your homework assignment, I'd like you to use a ruler. When you're doing this in your notebook for notes, you can just sketch the lines. So I see this line here. Well, now I need to do the same thing for my next one. I'm going to turn it into slope-intercept form. To do that, all I need to do is to take away 1/3 x from both sides, and I'm left with y equals a negative 1/3. Ooh, that's a rough looking 3. Negative 1/3 x plus 0. Well, to have the simplified form, I can get rid of that plus 0, but I'm going to put it there as a placeholder for my slope-intercept, and that tells me my intercept is 0, and my slope is, again, down 1 over 3. Down 1 over 3. When I connect and extend, well, my lines aren't beautifully perfectly straight, but I should be able to recognize that these are parallel lines. So my final answer for the number of solutions is no solution. There's no point that makes both of these equations true. And I can do that even before I graph them. I should be able to recognize when I see this m value of negative 1/3 and an m value of negative 1/3. I can tell that my slope is the same, so then I just need to check my intercept. Is my intercept the same, in which case I would really have the same line, or is my intercept different, in which case I have parallel lines? So my final answer is no solution, but if I think back to my other terms that I was learning today, consistent, inconsistent, dependent, independent, I can say that this system is also inconsistent. There are no solutions. Well, let's try again. One more graphing practice here. This time they are already in slope-intercept form. So I'm going to graph the first one. Let's do blue for the first one. I'll start at my y-intercept of positive 3. And that slope tells me I go up 1 over 2. A slope of 1/2 is up 1 over 2. I'm going to connect and extend. Ooh, that's really messy. Let's try that one again. That's a highlight. Here's my eraser. There we go. We are going to connect across. Where's my pen? There we go. Connect and extend. My blue line here. And then for my other one, we'll go with green this time. I have 2x plus 3. So again, I'm going to start with that y-intercept of positive 3. Hey, look, I have at least one solution already. And a slope of 2 tells me I go up 2 over 1. Up 2 over 1. Messy lines here, but you get the point. If I see this here, I know that there's going to be one solution. This is a consistent independent system. My one solution is that spot where those lines cross each other. That ordered pair, we always list our x value first in our ordered pair and our y value second. So this has one solution, and the only solution is the ordered pair 03. Your job tonight is the worksheet that's posted on Teams. If you're in the classroom, you were handed a copy of it. If you're at home, please print it out and solve it on paper. If you don't have access to a printer, that's okay. You can solve it on paper and take a picture of your paper. Make sure that you get this uploaded by the due date, and we will keep moving through chapter 6. Thanks, guys.